All right, so we're going to continue our conversation about, all right, transformations in the coordinate plane. And today we're going to look at our third type of transformation, all right? After we've talked about translations, reflections, we're now going to talk about dilations. All right, so you can see that standard 11.3. I can dilate figures by a scale factor in the coordinate plane. All right, so to kind of get us thinking about what a dilation may be, we have an opener for you to complete here. All right, so I would like you to do parts A and part B here. So follow the rule given here for you for both A and B. All right, find your image, all right, of our triangle fun here. All right, so pause the video, do that work, flip it back on, and we'll see how you did. All right, now I'm going to show you my work for these. All right, so when you look at these, notice how these are different, all right, than the prior transformation we have performed in a coordinate plane, right? So notice everything we've done so far with reflections and translations were what we called isometries, right? They preserved shape and size, right? So notice what happened in both of these problems for the opener, right? The shape was preserved, but not the size, right? So when we look at part A, we had triangle fun here, and notice it got enlarged, right? Okay, it's now bigger than it was, but it's still the same shape, right? When we look at triangle FUN over here, all right, this time, all right, it got reduced or shrunk, right? So now it's smaller, okay? And so hopefully, what did you notice about both of these? All right, that they're the same shape, but their size changed, right? So these are not an isometry, all right? And what these actually are, and you may have guessed this, right? So a little bit of a lead in here. These are both dilations, okay? All right, so now that's what a dilation is, all right? It is just a transformation, all right? So if we go down here, all right, okay, and look at our definition here. A dilation is a transformation, all right, that, okay, enlarges or reduces our image, right? I should say our pre-image to image. Okay, all right, about a fixed point. Almost left that out. All right, fixed. I'm having a hard time writing this morning. Need some more coffee. All right, about a fixed point. All right. Okay, so a transformation that enlarges or reduces our pre-image to image about a fixed point. All right, and I'm just going to put CR opener here, right? Because that's exactly what happened in our opener, right? So if I go back and put that work up there, right? Okay, so we enlarged here, all right, and we reduced here. So that's what a dilation is. Now, when I say about a fixed point, that's really what, all right, our center of dilation is, right? This is the point about which the dilation occurs. All right. And so for us, right, it's always going to be the origin. So 0, 0 is always going to be, all right, our center of dilation. Okay. And so basically everything we do, all right, is going to be in reference to 0, 0. All right. So it doesn't really change the process. All right. So for what we're doing, right. And so basically, right, if we think about like we might have a box like this, right. And if we want to enlarge that box, all right, it would still be about the origin like that. Okay. Or in reference to the origin. Okay. Now, notice when we look at this, we're enlarging or reducing. And what we call that enlargement or that reduction of our pre-image to image, we call that the scale factor. And so this is the amount that the image, all right, is enlarged or reduced, okay, compared to our pre-image. All right, compared to the pre-image. All right, so for example, let's say we had an equilateral triangle, right? And it was 2, 2, 2. And then we did a dilation and we enlarged it, all right? Preserves the shape, but the size has changed, right? Okay, so now it's 4, 4, and 4. So we would say, all right, that the scale factor here would be 2. So that would be equal to 2. So it's twice as large, right? So the scale factor is just how much do we enlarge or reduce, all right, that figure. All right, so let's take a look, all right, at the next page here. All right. Okay, and then this really just summarizes, all right, everything that we just talked about, right? So a dilation is a transformation in which a figure is, all right, enlarged or reduced, all right, with respect to a fixed point. And that fixed point is the center of dilation, all right? Okay, so now, all right, to dilate or find out how much a figure was dilated by, we need to know, and we call that the scale factor, right? And so basically, scale factor, which just OR there, all right? Now, so basically that's going to tell us if it's going to be an enlargement or a reduction, right? So if our scale factor is bigger than 1, all right, we know that it's going to make our figure bigger. All right, if our scale factor is between 0 and 1, all right, it's going to make our figure smaller. All right, and we need to know the center of dilation, right? All right, and like I said, for everything that we're doing here, all right, it's going to be the origin. It's going to be 0, 0. All right, so now, once again, I just said this, I kind of answered the questions ahead of time. If we go down here and look at our practice, right? What happens when the scale factor is greater than 1? All right, the figure will get bigger, right? All right, the image will be bigger than the pre-image. All right. What happens when the scale factor is less than 1? All right. When it's less than 1, and I really should say between 0 and 1, we will not have a negative scale factor, so it'll be positive. All right. It's going to be the image will be smaller than the pre-image. All right. Okay. Now, if the scale factor is equal to 1, it's going to be the same size. We'll say size is preserved. Right? So if I multiply by 1, nothing's going to move, right? Nothing's going to change, right? It's going to have the same size, okay? So there you go. All right. Okay, so now let's look at a problem or two, all right, to see how you process this. All right, so now we want to look at our figure here, small, all right, or lambs or malls, all right, whatever, however you want to say this, pronounce this, or wherever you want to start that, all right? So we want to, all right, dilate this figure by a scale factor of 2. All right, so our original point. So if I look at M, my original point for M is 1, 2, all right, so negative 2, 2. All right, my original point for A, all right, is 1, 2, 3, 2. For L, my original point is 3, negative 2. And then for S, it is 1, 2, 3, 4, negative 1. Negative 4, negative 1. So those are my original points. Okay, now my scale factor is 2. All right, so my scale factor, all right, I'm going to apply to all these points is 2. And now here's all you have to do. You just multiply each part of your point by the scale factor. So I multiply the x coordinate by 2, the y coordinate by 2. So then my dilated point for here, which would give me m prime, all right, would be negative 4, 4. So negative 4, 1, 2, 3, 4, and there's m prime. All right, to get a prime, I would multiply this by 2, and that would give me 6, 4. So 5, 6, and then 1, 2, 3, 4. So there's a prime. And then to get L prime, multiply that by 2, and that would be 6, negative 4. All right, so there's 6, and then 1, 2, 3, 4. So there's L prime. All right, and then to get S prime, same thing, multiply this by 2, and that would give me negative 8, negative 2. So negative 8, so there's 5, 6, 7, 8, negative 2 would be right there, and then there's S prime. And then if I just connect my vertices here, all right, you can see, even though my hand's a little bit shaky, need that other cup of coffee like I mentioned earlier, all right, the size has changed, but the shape is the same, right? We still have the same general shape, right? It's just now larger, all right, and you can see that our frame of reference, our center of dilation is 0, 0. And that's all right, you have to do with dilations. All right, so I'm going to turn this off now, all right, have those notes ready for class tomorrow, and I will see you then.